Evaluate the following expressions given f of x equals 5x, g of x equals x cubed plus 2, and h of x equals x squared plus 2x. Number 1, f of 3. To get f of 3, we're going to plug 3 into the f function every place we see an x. So instead of 5 times x, we have 5 times 3, and we evaluate and get 15. Next question, g of 2. G of 2, we go to the g function, which is right here, x cubed plus 2, and every place we see an x, we're going to replace it with 2. So this is, g of x is normally x cubed plus 2, but instead of x, I'm going to plug in 2. So 2 cubed is 8, plus 2 is 10. Next one, h of 1. So we're going to go to the h function. Every place you see an x, we're going to replace that with 1. So this is normally x squared plus 2 times x. But those x's we're going to replace with 1. And then to evaluate, 1 squared is 1, plus 2 times 1 is 2. We add these together and get 3. Number 4, f of a. This says we go to the f function, and every place we see an x, we're going to replace it with a. So instead of 5 times x, we have 5 times a, and there's not really anything we can do to simplify this, although we could write it without parentheses as 5a. Next, g of c plus d. Let's take the g function and write this out. This is x cubed plus 2. But every place we see an x, we're going to plug in c plus d. Now we could do some algebra on here to simplify this. I guess we'll do that now. If you go through the distributing process, you're going to get that this is c cubed plus 3c squared d plus 3cd squared plus d cubed, and then don't forget the plus 2. Next up, we have h of x plus 1. So for this, we go to the h function, which is x squared plus 2x. So x squared plus 2x. But every place we had an x in the original function, we're going to replace that with x plus 1. So we have x plus 1 squared plus 2 times x plus 1. Then let's distribute this out. X plus 1 squared, if we distribute that, we get x squared plus 2x plus 1. And then if we distribute the 2 to both terms here, we get 2x plus 2. And then finally we can combine like terms to get x squared plus 4x plus 3. Then on to the composition problems. F of g of 1. For this, I'm going to focus on the inside first. So the f function on the outside, I'm going to leave that alone. Now plug 1 into the g function to figure out what's going to go in the parentheses here. So g of 1. We go to the g function. Every place we have an x, we replace it with 1. So this becomes 1 cubed plus 2. Simplifying the inside, 1 cubed is 1, plus 2 is 3. And so this has simplified so far to f of 3. Now we plug 3 into the f function. So instead of 5 times x, this is 5 times 3. And we multiply those together to get 15. Next, problem number 8. Now notice this almost looks the same thing, but the g and the f are in reversed order. So we're going to focus on the inside first. So this g that's on the outside, I'll just leave that there. So this is g of something that we're going to determine. And then f of 1, we go to the f function. F of x equals 5x. And every x that we see there, we're going to replace with 1. So this becomes 5 times 1. So simplify the inside. So we've got g of 5. Now that we're done with the inside, we're going to plug 5 into the g function. So g was x cubed plus 2. So we're going to replace the x that we have here with 5. So instead of x cubed plus 2, we have 5 cubed plus 2. And simplifying this, 5 cubed is 125, plus 2 is 127. Number 9 is f of g of h of negative 1. Now this looks really intimidating, but we're just going to handle these one at a time. The f function is on the outside, and we'll leave that where it is. The g function we're not ready for because we're going to analyze the inside first, so we'll leave this as f of g of something that we're going to figure out. Now h of negative 1. That says we go to the h function, which is up here, and every place we see an x, we're going to replace that with negative 1. So this gives us negative 1 squared plus 2 times negative 1. Simplifying what's in the parentheses, we have f of g of, well, negative 1 squared is 1, and then 2 times negative 1 is negative 2. Combining those together gives us negative 1. We've got one function down, 2 more to go. Now we're going to handle what's on the inside first. So we look at g of negative 1. So we go to the g function, and every place we see an x, we're going to replace that with negative 1. So this is f of negative 1 cubed plus 2. Now we simplify what's inside the parentheses. So negative 1 cubed is negative 1, plus 2 is positive 1. So this is f of 1. And then finally we're down to our last function. So we're going to go to the f function, and every place we have an x, we're going to replace that with 1. So this, instead of being 5 times x, it's 5 times 1, which we simplify to 5. Now into the last set. Number 10, f of g of x. Well, we're going to handle what's in the inside set of parentheses first. So g of x, now we don't know what x is, so we're going to plug in what we know. G of x is x cubed plus 2. We just replace the inside function with what its value is. Next, we're going to go to the f function, and every place we have an x, we're going to replace that with x cubed plus 2. So instead of being 5x, this is 5 times x cubed plus 2, which we can simplify by distributing to give us 5x cubed plus 10. Number 11 is g of h of x. Like before, I'm just going to leave the outer function as it is. So this is g of. Now h of x I'm going to replace with the value we have for h of x, which we have up here as x squared plus 2x. So I'm going to write that in our g function. So this is x squared plus 2x. Now that we've simplified the inside function as much as possible, we're going to plug that into the g function. So we go to g of x, which is x cubed plus 2. We're going to replace every x that we see here with x squared plus 2x. So this gives us, normally we would have x cubed plus 2, that's the definition of g, but we replaced x with x squared plus 2x. Now we could distribute this out, but this is starting to get really messy, so we can leave this as it is. Okay, then finally, h of f of x. We're going to leave the outside function as it is, so we'll leave this as h of. Now we replace f of x with the definition we were given for f of x, which in this case was 5x. So this becomes h of 5x. Now that we've simplified what's inside the parentheses, we're going to plug this into the h function. So h was given over here as x squared plus 2x. So I'm going to copy this template down, x squared plus 2x. But I'm going to replace all of those x's with 5x. We can finally simplify this to give us 25x squared plus 10x.